Hello, this is Christian, Paul, Sid, Akil, and this is the radar cued camera detection system, and we are sponsored by Echodyne.
So the goal of our project was to develop a system that uses radar data to give inputs to a PTZ camera that then isolates a track and can capture images as well as label these tracks for the end goal of building up a database of labels to radar tracks that Echodyne will be able to use in the future.
We came up with a number of requirements for this project with the Echodyne staff at the beginning of the quarter. One, the system has to be easily deployable. We expect Echodyne technicians to be able to use this during field tests, but it should be able to be operated by non-technicians. Two, the system must display tracks from the radars on a map in real time. Three, the system must be accurate. When a user selects a track, the camera should point at the object the track refers to with a reasonable accuracy. Four, the user should be able to manipulate the camera manually through the UI. Five, images captured from the camera should be stored both locally and on a permanent database. And six, the associated data with those images, including the track radar information and any user annotations, should also be stored in the database.
For implementation, my part of the project was camera manipulation and location mapping. I did this using the camera orientation data to initialize the camera and the radar system. I also, so we did this via the Sunset Bar and track packets. Then we calculate the movements necessary for the camera to point towards the location that the track packets indicate. And after all that is done, we add displacement vectors onto the calculated movements so that the errors can be corrected if they're introduced during the initialization function or the direction calculation function.
For my scope, I worked on the user interface for both image capture, relative movements, and live labeling. So Echodyne has a existing software that can go ahead and output radar tracks called Echo Guardian. And so my task was to go ahead and modify the existing repository and add some features that would support our system's requirements. So this system would be able to handle some incoming radar data. The user would be able to select that radar data and pass that information of the selected track to another part of the code using Redis. And we'd use some existing libraries that this Echo Guardian piece of software already contained, which is Bokeh, and then I'll also use OpenCV to handle streaming the camera feed.
For the image and related data storage, we use existing Echodyne software, so primarily Postgres, to store the image and track related data. Locally, the data is stored within a JSON file, and then when the field operator has access to the internet, they upload that JSON file, which contains the entire field runs data, to a Flask web server that communicates with the permanent database.
And finally, I worked on the labeling tool, which queries the permanent database to view images. You can filter on all the relevant fields, such as label, live labeled, camera serial number, and additionally apply labels that are stored in the database using, and this was created using Flask for the web server and HTML for the visual components, as well as JavaScript.
Now for the demo portion, we did all of our field testing at Gasworks Park. As you can see, it's a really nice open area of Lake Union, and we also have nice large tracts of like boats as well as seaplanes and kayakers. This is the radar that would detect these tracks out in Lake Union, and then this is the camera that will go ahead and stream the feed of whatever we prompt to view. So this is the UI for Echo Camera. As you can see, there is a radar map The blue shadow is the field of view of the radar, and we can go ahead and box select these moving radar tracks, and then go ahead and type in a input into the search labels box, and whatever labels that contain that input can go ahead and be selected and attached to the captured image. This capture button goes ahead and essentially captures whatever the image is. We don't have the camera stream going right now, but in the next video, we'll go ahead and see that. You also have a most recently used labels option that can go ahead and expedite the process of adding labels to these captured images. And then you can also go ahead and add custom labels that aren't in the options below. And then you can also just go ahead and customly add any label to a selected image as well. These buttons right here are relative camera movements. And then as you'll see in the next video, these will go ahead and refine the camera feed such that you can capture a better image.
This first example is of a small target about 200 meters away. This target is a kayak, and since it's such a small target, we wanted to make sure that we adjusted the camera and got a better shot of it. We use the labeling tool here to give it the kayak label for our database. The second example is of a larger target about 100 meters away. As we did with the prior example, we adjusted the camera to get a better view of the target. We decided to input this one without a title. The third example is of a boat about 600 meters away. This example shows the difficulties of achieving higher accuracy at further ranges. This can be seen by the adjustments that are being made. The fourth example is of a group of kayakers about 50 meters away. At the start of the example, we move off of a prior target that was in the air. This results in some time for the camera to be able to adjust. The last example is of a boat about 500 meters away. No adjustment was needed for the camera, and we are able to wait for the shot to stabilize. We then use the recently used labels tab to label the target as a powerboat. We capture an image and ready it for our database. We decided to show the view from our perspective as it shines a light on the relative size of the object in comparison to the rest of the environment.
Now we're going to take a look at how data from a field run is actually stored. So data from a field run is stored within a JSON file, just a large JSON file for every image that is captured and associated track information. This data is then uploaded to a web server that communicates with the permanent database. Web server is hosted on Flask. And users can upload the test data, the JSON file. They can also upload the images to the permanent database. And both this data and the images can be read and written to by the labeling tool. Oh, and as you can see here, the images are stored within the database.
All right, and then the final portion of our system is the post field test labeling tool. So first you sign in with your Echodyne alias so we know who's applying these labels. Then this takes you to an explore page where you can first filter based on the date, either an exact date or a range, a label, the labeler, whether it was live labeled, and the serial numbers. As well as you can just explore the available the available captured images from field test, and you can see that Paul labeled a couple, but not all of them. And we are, this is just the explore feature being shown. And then Now we can filter. So let's see, we're gonna filter for airborne jet. And we can see there's only one of those. And we can remove this filter. We can filter for the labelers. Right now, it's just the database that Akil uploaded. So Paul's the only one. He was logged into the field test, so all the labels are his. And at this point now, we can demonstrate the label image functionality. And so this is the label image page. This did not have a label applied to it. And we can go to the next image. At this point, decide to apply a label, apply unknown label, and then we can confirm that this has been added to the database, because here we will see, and it's false because it was not live labeled, has my alias, and then we can demonstrate filtering on another category. Can't demonstrate the date and radar serial number and camera serial number because they're all the same, but you can rest assured that those filters are working. And yeah, I think that about summarizes all the functionality. Here you can see if a label's been applied, it shows up at the top of the view screen. And I think at this point, we just go ahead and continue to demonstrate. But that wraps up our project.